Now I'm going to guide you through solving a system of three linear equations using its augmented matrix, and we're going to use Gauss-Jordan elimination. Okay, so for this example, use Gauss-Jordan elimination to solve. And the system that we're going to solve is 2x minus y plus z equals 11, 3x plus 2y minus z equals negative 5, and 4x minus 2y minus 5z equals 1. So that's our system. Okay, so the first thing we want to do is convert this to its augmented matrix. So go ahead and see if you can do that using proper notation, and then come back and see if you got it right. Pause the video and then come back. Okay, so you should get 2, negative 1, 1, 11, 3, 2, negative 1, negative 5, 4, negative 2, negative 5, 1, with a vertical bar and brackets. Okay. Now in Gauss-Jordan elimination, our goal is to get our first column to be 1, 0, 0, our second column to be 0, 1, 0, and our third column to be 0, 0, 1, and then the constants over here will be our solution. So the first thing we're going to do is we're going to go in the first column, we're going to get zeros here. Okay, so and I'm going to use this 2 to get a 0 for both places. So what we're going to do is I want you to do this. If I want to use the 2 to eliminate a 3, I need both of those numbers to be a 6. One of those to be positive 6 and one of those to be negative 6. So what I'm going to tell you to do is make the positive 2 into a negative 6. And you do that by taking negative 3 times row 1, which is, so that's going to change this 2 into a negative 6. Now we need to change the 3 into a positive 6, so we'll multiply row 2 by 2, because 2 times 3 is positive 6. And we add those together to get 0, and we want to replace row 2, right? We want a 0 right here. So that's going to give us a new row 2. Alright? So we can do that in a second. We'll do those operations to actually calculate our new row 2. But now let's focus on how to get rid of the 4. So to get rid of the 4, I'm going to tell you to change the positive 2 to a negative 4. So you take negative 2 times row 1 to make that 2 into a negative 4, and then add it to row 3, and we want to replace row 3 to get a 0 here. So this will be our new row 3. Okay? So why don't you pause, work out both of these row operations, and see what you get for your new row 2 and your new row 3, and then come back and check to see if you got them right. Okay, your new row 2 should be 0, 7, negative 5, negative 43. Your new row 3 should be 0, 0, negative 7, negative 21. Okay? Now, before you go and write the equivalent matrix, which by the way, in our new matrix, row 1 didn't change. We just got a new row 2 and a new row 3. So let's copy row 1 real quick. 2, negative 1, 1, 11. Row 3, our new row 3, notice that both of these guys are divisible by 7. In fact, they're both divisible by negative 7. So what we're going to do to make this row easier to work with is we're going to go ahead and divide it by negative 7. Okay? So go ahead and do that, and we'll write our new row 3. So our new row 2 is 0, 7, negative 5, negative 43. And our new row 3 is now 0, 0, 1, 3. Don't forget your vertical bar. So row 3 ended up being really nice because we got a 0 here already in our second column. We weren't even trying to do that. And we have a 1 here, right? We have these entries already what we need them to be. Excellent. So now we've taken care of the zeros in column 1. That's what we worked on first. Now we're going to move over to column 2 and get zeros above and below this middle entry, above and below the diagonal. Right, we're always using our diagonal entries to get zeros above and below. And we work from first column to second column to third column. Alright, so now what we need to do is move to our second column. Here's our diagonal entry. We're going to use him to create a 0 there. And we need a 0 here, but that one's already done, so we don't have to do any work there. So all we're going to do is try to get a new row 1. Okay? So, if I want to do that, then I want my 7 and negative 1 to cancel. Well, if they were both 7s, they would cancel, where one of them's positive 7, one of them's negative 7. So I'm gonna leave my row 2 as 7, but I'll change my negative 1 to negative 7. So that's going to be row 2 plus 7 times row 1. That's going to give me my negative 7 there. And then I need to add those together, right? I need to add those together to get a new row 1. I'm trying to replace row 1. And that's the only row operation I need here, because I've already got my 0 down here in my third row. So pause the video and work out that row operation and see what you get, and then you can come back and check your answer on that one. Okay, so your new row 1 should be, you should have 14, 0, 2, 34. Okay, so that's good. But you notice that all the numbers here are divisible by 2. You don't have to do this, but it sure makes these more bearable to work with. Just go ahead and divide the row by 2 to make the number smaller. Now, this is my new row 1, so that means my row 2 and row 3 didn't change. So let's write our new augmented matrix. Row 1 is my new row 1, which if I divide by 2 is 7, 0, 1, 17. Row 2 remains the same, and row 3 remains the same. So now I've got my zeros in my below my diagonal in my first column, my zeros above and below the diagonal in my second column. Now what I want to do is move over to my third column and use this diagonal entry to cancel these guys, make these guys zeros. Okay? So now I'm going to use the 1 here in my third row to eliminate the 1 in my first row. So what I'll do is I'll make the 1 in the third row a negative 1, and then I'll add it to the 1 in my first row. So I'll do negative 1 times row 3 plus row 1, and that's going to give me my new row 1. Okay, we'll work that out in a second. Now I want to use the 1 in my third row to eliminate my negative 5. So I'll turn my 1 into a positive 5. So I'll do positive 5 times row 3 plus row 2 equals, and I want a new row 2. Okay? Work out each of those row operations while you've got the video paused, and then come back and see if you got those right. We're almost done. So your new row 1 should be 7, 0, 0, 14. But everything there is divisible by 7, so we're actually going to divide those by 7 to get 1, 0, 0, 2 for my new row 1. My new row 2 should be 0, 7, 0, negative 28. And those are all divisible by 7, so let's go ahead and divide by 7 there as well to get 0, 1, 0, negative 4. And then we'll write our new matrix. So my new row 1 is this stuff divided by 7. So that's 1, 0, 0, 2. My new row 2 is right here, this stuff divided by 7, so 0, 1, 0, negative 4. And row 3 never changed. I don't have a new row 3, so I just copy 0, 0, 1, 3. And that's it. I already have 1s on my diagonals, right? I got all my zeros. That's what we work on first. Get the zeros in each column, leaving the diagonal alone. And at the end, if any of these is not a 1, you can divide that row by whatever you need to make it a 1. But here, they happen to be 1s already. So this is reduced row echelon form, meaning that these numbers are the solution to the system. So the solution is the order triple 2, negative 4, 3. And you can check that by plugging in that x, y, and z values into the original equations, and you'll see that it makes all 3 of those true. All right, it's been fun. I hope that all made sense to you. It's good to practice this, and I wanted to guide you through one before you go tackle these on your own, just to make sure you're getting each concept correct throughout. That way, working on the small pieces and correcting your mistakes as you go can be tremendously helpful. So I hope this was helpful, and good luck.